first in so you get the best chair. If you'd like to sit yourselves down. First thing I really want to emphasise is that the main design function of the buildings, the things that they looked at right at the beginning, was trying to reduce the energy demand in the house. So trying to reduce...
One of the most successful parts of the BedZED development is the energy efficiency of the buildings themselves. So they've been constructed in a way that reduces energy demand for heating by 90%.
We don't need radiators, we don't need fireplaces. Now if you look at this wall here, you can see how thick the wall is. And inside there we have 30 centimetres of insulation, which means...
A large quantity of insulation has been put all around the building envelope using rock wool insulation, so that's provided a kind of blanket. There's also been a high thermal mass incorporated into the buildings to help regulate the temperature throughout the day and night.
Because it's so well insulated, we do need additional ventilation, so that comes from a series of wind cows. And also, in this room here, there's a hole in the corner. The cooler, fresher air comes into that hole, but we need also an exhaust. Hot air rises, and the hot air leaves through that exhaust. The cooler air drops into the corner of the room there. A couple bits of orientation. As I mentioned, that's south. That's north.
The orientation of the buildings means that all of the residential developments face south, and on the south facade there is a sun space, which is like a conservatory, but it's got a double layer of glass in it, and the outer layer is double glazing and the inner layer is also double glazing, so that provides a large heated area that then balances out the temperature of the building overall.
The heating system of the living spaces here are under the control of the people who live in them, either by opening or closing different doors, windows, without just turning up a thermostat. My energy costs are way less.
On the heating side, it makes savings, obviously, and from a financial point of view, it's good. But obviously, you want to reduce your carbon footprint, and on your conscience side, yeah, that's a brilliant thing.
We've reduced electricity demand at BedZED by around 25%. Firstly, through the good design of the buildings, which allows plenty of natural daylight, so reducing the need for artificial lighting. There's also energy efficient lights in all the buildings, very low energy appliances, including A-rated washing machines and fridge freezers. And we've installed solar photovoltaic panels in the windows and on the roofs of the buildings. These supply electricity for the car charging points, which are capable of powering up to 40 electric cars. As the electric car industry is only just taking off, the PV panels primarily provide electricity for outside lighting at the moment, and the remainder is fed back to the grid when we've got any excess. The initial plan to power the site was to have a biomass combined heat and power system using wood chips from local street trees. Wood chip is then turned into a gas, and then that's used in an engine to produce heat for the hot water and also electricity. We've made some very energy efficient buildings, and that's actually meant that there wasn't sufficient heat requirement for that combined heat and power system to run efficiently. And we now know biomass combined heat and power system would operate for something more like 5,000 homes. So we're now using 3 gas condensing boilers to power the heat for the site, and we're getting electricity from the mains grid and from our solar photovoltaic panels that we've got on the site. It was very much a cutting edge technology at the time, and I think there's a lot of lessons being learnt for the CHP industry from that. We've got a boiler house now that we can put different technologies in, and we're currently investigating installing a biomass boiler in there instead, so it wouldn't generate electricity but it would generate heat for the site.